Both. Okay. So first we have so the probability starts with the basic concept of probability and other things. Let's go through one by one. So if I have a coin, so for a coin, are the possible outcomes like head or tail, right? Like for a die, we have the possible outcome like any number in between 1 to 6. So firstly, we have something called as experiment. Experiment means any action whose outcome is unknown. Okay, any action we are doing, what will happen we don't know. I am tossing a coin, I don't know what will happen. In between you should be you should be chatting. Okay, I'll be seeing your chats. Just respond in between if anything is there, so that I can understand that you are in the class. Then I'm saying like anything I'm doing. Okay, I'm doing some action, but whose outcome I don't know. But I know what are the possible outcome it can take. So for if I toss a coin, I know the possible outcomes like it can be a head or it is a tail. For a dice, it is like number between 1 to 6, but I don't know what exactly will come if I roll now. So that is called as an experiment. Then it is exactly for random experiment. The definition, it is random. The experiment outcome is not known, it is called as random experiment. Next, so I have told you examples. Then we have something called a sample space. Sample space. So it is the set of all possible outcome for an experiment. So if I just have the set of all the outcomes which are possible for a random experiment, it is called as a sample space. For example, the sample space would be something like this, that is head and tail for tossing a coin. It will be like something like 1, 2, 3, 4, 5, 6 for a tossing of coin. It will be something like this: king, the queen, those things, the deck of card, multiple things. Okay, I know all the possible outcomes. I'm making a set of it. Then it is called as a sample space. So that's it. Then we have types of sample space. These are basic things. That's why I'm a little bit fast. But let me know if you are having any doubt. Okay, not an issue. I'll just slow down in that time. We have types of sample space like discrete and continuous. Discrete sample space and continuous sample space. So discrete means here the number of outcome is kind of finite number of outcome, or you can say countable. So it is having countable or finite number of outcomes. Finite number of outcomes, that is called as discrete. So example like tossing coin, all those things, rolling a dice, except rolling a dice, rolling a die, it is singular. Okay, these are called as discrete sample space. Next we have continuous sample space, where the values is not finite, it is uncountable. Continuous sample space, where the outcome is in a interval. If you remember the open interval, closed interval, that is the interval I'm talking about. Or you can say the outcomes are infinite, or I can say uncountable. Like temperature in a city. So it can be any value, right? It can be like 24.3, 24.34, like that. Any number it can be, degree Celsius, like that. Okay. Or like something like stock market prediction, or anything else like the weight of a person in a group, like that. Any doubt in this discrete and continuous sample space? Okay. Based on this, we'll be having different types of probability types. Okay, discrete probability and continuous probability, mainly because of the sample space which we are having. Okay, we'll be dividing it to multiple different things. Now, next subtopic is event. Event is simply, you can say, like, it is a event. It is a subset of sample space. For example, A be a event of getting hit. It is an event, or you can say B is getting a even number in dice. So these are events. Like, so you can see this. This is a subset of the sample space of head, comma, tail. Okay. So this is the subset of the sample space of dice like 1 to 6. So this is a subset. Like, I'm considering few conditional outcomes from the sample space. Then it is called as an event. Okay. Then we have types of events. So can I go to types of events now? Any doubt in this? These are all basics. Just I'm going through this so that we can have a complete comprehensive course. Can I move to the next? Okay. Now, types of events. One is mutually exclusive events. So any two events are called as mutually exclusive. Two events, A and B, are said to be mutually exclusive if there is no common things in between them. That is, in set terms, it is the intersection between those two set is null set, or you can say there is no common outcome between the events. Okay. For example, getting a even number when I roll a die, that is first event you can consider of. And second event might be getting an odd number when I roll a dice. So if you see the common part in between those two, it will be a null set. There will be no common part. For example, A is a set of all even outcomes of a dice. Second, you can say like set of all odd outcome of a die. Then that is, let me write in the actual values terms, like it is in the set roster form well, right? This is set builder form. This is roster form now. This is what we get. There is no common things in between them, right? It's a empty set, or you can say null set. So these events are mutually exclusive. Okay, there is no relation between those two things. Like they are separate. That's what I'm saying. Okay. Next, independent events. So independent event says the outcome of one event is not dependent on the outcome of second event, or the occurrence of one event is independent of occurrence of another event. That is called as independent events. So, for example, so the occurrence of one event is not dependent. That is independent, you call, on occurrence of another event. So first I'll make you understand what are dependent events. Dependent events will not be taking, but should be knowing what is a dependent event. For example, like getting a rainbow. All right, getting a rainbow is dependent on rain, having a rain. Is it true? So suppose there is an event A called as having a rainbow in a day. Second, B event is getting having rain. So I'm saying the event A is dependent on B. Is it true? Is it dependent? So yeah, see, rainbow, to get a rainbow, it is dependent on two things. One thing is it is dependent on rain, and another thing it is dependent on sun. Sun will be always there, okay? Sun will be always present in the daytime. But when the rain comes, when the both are in the some amount of what I can say intensity, then you see the rainbow. So if there is no rain itself, how will you get a rainbow, right? So that's what I'm saying. Leave the sun. Anyhow, sun will be there always. But rain is important for rainbow here. So getting a rainbow is depend on having the rain, right? That's what is dependent event. It is the event are dependent here. Independent means so uh, so suppose like I'm scoring good marks in a, so you scoring a good marks, suppose scoring good marks in suppose statistics. This was the event. B event is suppose example like India winning cricket. Is these two things depend? I don't know whether it is dependent for you or not. I don't think so. It is dependent for you. If India wins the cricket, you will not be or something like that. So if that is the case, huh? If India wins, if you don't study, then it is a dependent event. Else, it is a independent event. For example, so it is all perspective. So I hope you got what I want to say here. Independent events. So the occurrence of one event is not dependent on occurrence of second event. That's what I am saying. But it might be mutually exclusive. There might be common things in between. But yeah, that's what I'm saying. Okay. Okay. Next. Okay, we'll be seeing about probability space. Probability space means what is the range of probability, or you can say what is the domain of probability, in what values you may get the values for probability. That's what is called a probability space. So it is So the probability of any event is in between 0 and 1 always. Always. Okay. So P of an event, probability of event will be greater than 0, or it will be equal to 0 first of all, if it is an impossible event. Like the event is not possible. So suppose getting a number 2 when I toss a coin, is it possible? No. Then getting 2 heads when I toss a coin for a single time, not possible. So these are impossible events. Next, if any event having value 1 as the probability, then it is called as what is that? It is called as certain event. Okay, means that will it will be always happening. So having air in the atmosphere, it is always there, right? Like that, or you can say some other things, some better things you may be giving, but it is always be having. So it is always true. Those things are called as certain event, and the things which will never happen, that will be called as a impossible event. Or you can say here it is not called as possible; it is called as certain. The difference you should be knowing. Certain and possible means it may happen or it may not be happening, like that. There is a doubt, but certain means it will definitely happen, like that. Okay. Next. So one more thing. So the union of, okay, all the possible events on a sample space. Okay, suppose union of A1, A2 till AN, which are all possible events on sample space, okay, is a subset of sample space first of all, because it is a first of all it is the uh, anyhow an event is a subset of sample space. You can just remember that one thing. And if it is, if these things, okay, suppose these events like A1, A2 till AN, all the possible events on a sample space, if they are mutually exclusive, means what is the meaning of mutually exclusive? There is no common things in between them. Then any pair of set, any pair of AI and AJ, the intersection between them will also be a null set. So if I have some n events on a sample space which are all mutually exclusive, okay, then any pair of two events in that set will be a null set again. Okay, so that is one thing. And if these events, these all n events may be mutually exclusive and mutually exhaustive. Mutually exclusive means there is no common things in between the pair of events. Okay. Mutually exhaustive means it will be, if I make the union of all the events, yeah, okay, I is equal to 1 to n, then that sample space minus union will be equal to a null set. So I'm making the set difference here. So if I union them, all of the events which are mutually exclusive, and if the sample space, if I remove that union of those sets, if it is getting a null set, then it is called as mutually exhaustive. Let me know if you have doubt on this. It is very important to understand what is mutually exhaustive. For competitive exams, they'll say the events are mutually exclusive and exhaustive. So you should be knowing what is exhaustive meaning, right? Still, I'll give an example. So I have the sample set like okay, I have the sample space like is equal to head and tail, right? For a coin toss for single time, and I tried mutually exclusive event like A1 is equal to just head, A2 is equal to just tail. So is A1 and A2 mutually exclusive? Is these two mutually exclusive? Yes, because the intersection between these two is a null set. Then the union of these sets, yeah, that is equal to union of head and tail, right? The total will be head and tail. If I minus that with sample space, that is also head and tail. You'll be getting a null set, right? That is what mutually exhaustive means. So it is important to understand it is just removing everything from the sample space, the union of all the events which are possible on a sample space. Clear the mutually exhaustive topic? Okay, move forward. So we have just completed the random experiment sample space. We have completed. Now we'll be going through the algebra of events. Okay. Next topic, algebra of events. Okay. Now algebra of events. Before that, we should be knowing what is probability, right? Probability is the ratio between favorable events, favorable outcome for an event, to the total number of outcomes is called as probability. For example, probability of event is equal to number of favorable outcomes to the total number of outcomes. Okay, that is the probability. For example, my event E is equal to getting a head when I toss a coin. So the outcome is, so first we should be knowing what is sample space. Sample space is head and tail, because when I toss a coin for one time, the possible outcome for this is either head or tail. Now, in that, only this outcome is favoring my event, right? So it is only one thing which is favoring my event. Two, total number of outcomes is two possible. That is why the probability is 1/2. Okay. So this is the basic explanation, but we'll be building the entire thing on this itself. Okay. So the ratio between the favorable number of events to the total number of possible events. So you should be knowing. Now, still no? Can I move forward? Okay. Now, can we say the uh, algebra of events? Algebra of events will be same. Okay. In that, we have first is addition group. Addition rule is the probability of union of two events. Okay, that is equal to probability of A plus probability of B minus probability of A intersection B. Okay, let me explain this. So the union means either of A or B or both. Okay, so suppose my first event A is equal to the event of getting an even number. When when a die is rolled, then suppose B event is the event of getting a prime number. When a roll is die is rolled. Okay, this is in set builder form. Let me write it in roster form. So even number is 2, 4, 6, and B a prime number like 2, 3, 5. Okay. So now what is the probability of A? Just A. Probability of A is it is having three favorable outcomes to total 6 outcome. That is 1/2. Now probability of B is it's also having three possible outcome favorable outcomes to 6. That is also 1/2. Now I want to know the probability of A or B. Either an even number or a prime or a both. To find it that we'll just use this formula P of A plus P of B minus P of A intersection B. P of A is 1/2. P of B is also 1/2. Minus the common things in between two is one item, right? That is 1 among 6. So the final value is half plus half is full minus this value 1/6 is 5/6 it is. Okay, correct. So here what is happening, why we are subtracting these values, it is very important to understand. So the case is, here also I have considered 2 once, already 2 has been considered. Here also I am considered 2 again. So this 2 value which is common to these two, so if I write in Venn diagram form, the common things in between these two outcomes, right? The outcomes, possible outcomes, this common thing. I'm considering this for 2 times consider. That's why I'm removing that once. So remove it once. Okay, that's why we are subtracting that. Either of the events. That is the union operation. Okay. Yes. Next. Okay. Now the next thing in this is this is a general rule. This is general purpose rule. So if two events are mutually exclusive, what will happen? What are mutually exclusive events? Uh, yeah. So the intersection value will be null percent, right? So we don't need to use that when we are dealing with only mutually exclusive events. So the formula will change here. So formula will be changed in the case of mutually exclusive events. So it will be something like P of A union B will be equal to P of A plus P of B because there is no common things. You can just check whether it is giving correct answers or not. Okay. Next, this is the addition rule. Next, we have multiplication rule. Okay. So the multiplication rule generally we say for probability of the common thing in between those two events. It is generally the P of A dot P of B. It is a multiplication between the probabilities of two events, for the common thing. Okay. Now next. So probability of, so for independent event I'm talking about here, not dependent event, independent event. So they are not dependent. Like there is no dependency between the I hope now I'm audible, Ananya. Sorry for the disconnection. One second, let me share the screen. Is my screen? Now is it audible and visible? Now is it audible and visible? Okay. So conditional probability means for any event which is having greater than zero probability, then the probability of happening of the event B under the condition that A has already happened. Okay, an event which is B is the possibility of happening of event B under the condition that we know that probability the event A has already happened. That is called as a conditional probability. Here the condition is A has already happened. How? What is the probability of B now? Suppose, for example, to make an overview of this, I can say like the probability of rainbow after rain. So I'm saying that rain is already happened. Rain is happening or rain is happened. Then what is the probability of rainbow? That is called as conditional probability. Okay. So I'm saying you rain has already happened. Now what is the probability of rainbow? Like that I'm asking you. Okay. That is similar for a conditional probability. Let's see what is some example with this from discrete. Then we'll go to other things. So, for example, two fair die are rolled once. The probability that at least one of the result is 6, given that the results obtained are different. Okay. So that's what I'm saying. So here the case is two fair dice are rolled. The probability that at least one of them is 6, given that the result obtained are different. There will be no similar results, but it is different, they are saying. Okay. So let's do this. Different equals 1 by 3. Okay, the answer should be 1 by 3. Let's see this. Let's take an event A is equal to all the pair, like they are equal either. So A comma B, where A is equal to B and A and B are from this 1 to 6 number. So this is for similar output, similar values 1 1 2 2 3 3, like that 1 1 2 2 3 3 4 4 5 5. Okay, these possibilities there, and it can be ulta also. So this is I'm saying first die is 1, second die is 1. Okay, but it can be second die also 1 first die also 1. Are they different? No, it is same. There is no difference between those two. Okay, now 1 second. And let's take given B is equal to the pairs where A is not equal to B. How many such possibilities we have where A is not equal to B? So let me change this. This is not required here. I'll just change like either A is 6 or B is 6. How many possibilities are there for this? For A first. Either of the values is 6 or it can be both. How many such possibilities are there? Could you please answer this? Either of them is 6. That is means one of them is at least 6. How many possibilities are there? Waiting for your answer. No, because it is 11, not 25. See, it is first. I consider first value is 1. Second value can be, yeah, 6 2 6 3 6 4 6 5 6 6. I consider second value is 6. First value will be 1 1 1 6 2 6 3 6 4 6 5 6. Again 6 6 will not come because it is already considered. It is one outcome. It is not two outcomes. So total it is 11 possibilities. So the number of values in A is equal to 11. Now B is equal to A comma B, the pair such that A is not equal to B. How many possibilities are there like this? With this condition, A is not equal to B. It is simple. Just take the totalities and remove the yeah, correct. So total minus the similar ones, right? So total possibilities are here. They have 6 options into 6 options you have. That is 36 total. Minus the similar outputs like A is equal to B is 6. Then it is 36 minus 6. That is 30 for the B. That is n of B is equal to 30. Now we have asked that for this is for 36 options. This is for 36 options. Now we ask that A given B. So they are not equal. They are saying 2 dice are rolled, and the probability that at least one of them is 6. Given that the result obtained are different, so they saying the outcome will be different. Already it is said the B is said that is different means it is among this 30 which is there in the 36, and how many will be having 6 at least in one of them. That will be 11 by 36. The total answer is 1 by 11 by 30 is the answer. Okay. Is it correct? It is not direct. Here we need to apply the formula. Right? The formula here it is wrong. So the formula is P of A intersection B by P of B. What is A intersection B? Among this common is how much? So in these two, the common things is these 10 values, right? These 10 values will be common. That is 10 by 36 is the common things between A and B. Now B value, that is 30 by 36. So the answer is 1 by 3 is the answer. Okay. Just understand this, and if there is any doubt, you can ask me. So they are saying that outcome is different. First of all, outcome should be different. That is known thing. Being the outcome different, I'm checking how many outcomes are there which is at least having 1/6. Okay, that is the case. In other words, suppose like I'll just note that. So they're saying outcomes are different, like that is 30 outcomes. 30, which are different outcomes, right? That is 36 minus 6. Now, the possible which is having in this possible ones which are having 1/6, that is 1/6, like 1/6 in that. That is 1/6, 2/6, 3/6, 4/6, 5/6, 6/1, 6/2, 6/3, 6/4, 6/5. So the thing which we'll get is one among this set for 30, which are different values. That is why it is 1 by 30. That is 1 by 3. 10 by 30, it is 1 by 3. Ask me if you have doubt. It is very important to understand this. Just have a note of this. If you are okay, then we'll do one more problem. Okay, fine. Okay. Next, let's see one more last example for today. Okay. Mm, okay. So simple, I'll do. I have to take permutation combination, but I'll take it later. But still, I solve this. So a bag contains 5 red and 3 yellow balls. 2 balls should be taken without replacement. So you're not putting them back. Okay, that is without replacement. What is the probability that second ball being yellow given the first ball is red? Okay, so here consider this probability of A given B should be. So B event is, it is a red ball already taken. A is yellow ball. Okay, so I'll just simply solve this, but it is not the way of solving this. There is the other way. It will not be working out for every case, but still I'll try to answer this. So we know that first ball is taken is red. If I take out that ball, how many ball will be left in the bag? Total there are 5 plus 3, 8 balls. We know that first taken out, that is red ball. Yeah, it will be remaining 7 balls, right? Among 7, how much yellow ball will be having? 3. So the answer is 3 among 7. That's it. So we know that first ball taken out is red. So if I take the second ball, being it yellow, is the possibility is 3 among 7. That's it. Simple way of solving, but it is not the way. We need to see the combination and permutation. Then we'll understand this better. Again, I'll do the same problem. Then the answer will be same, but the way of solving will be different. Here also I can say like yeah. So here, yeah, we'll discuss this again. Not like I can't take it anymore now. So if you have doubt in this, you can ask. Okay, fine. We'll meet in the next class. Okay. Thanks for joining.